We will now introduce a new class of functions called logarithmic functions. So we'll add this to our library of functions, so we'll be able to do transformations and sketch the graphs of these functions. First, we'll look at the notation. So here I have y equals log base a of x. The log is short for logarithm, so this is read log base a of x, or log to the base a of x. So that subscript is the base. And it's important to read it properly in your head when you guys read these, to remind yourself that that subscript is the base. Y equals log base a of x is equivalent to saying a to the power y equals x. There's restrictions on this function. A, the base, has to be positive. A cannot equal 1. And x, we call x the argument, the thing we're taking log of, we're calling that the argument. It has to be positive. So if you just want to make a note here, the base must be positive. And if you want to label here, the base is the subscript, and the argument is the x. That's the thing you're taking log of. We'll call that the argument. Okay, now a special type of logarithmic function is this ln of x. We read this the natural logarithm of x. The natural logarithm of x is equivalent to a logarithm with a base e. Remember, e is that number that we studied in the last section, that 2.71, etc. So it has a base of e. So then y equals natural log of x is equivalent to saying e to the power y equals x. Then if we see a logarithm with no base written in like this, y equals log of x, this is called the common logarithm, and we assume that it has a base 10. So this is a log base 10. So if you don't see one written in, you know it's base 10. It's just like if you have a square root symbol. If you have a radical with no index written in, we assume that that's a square root. Well, here, if the log is written without a base, we assume it has a base of 10. So then we can say that log base 10 of y equals log base 10 of x is the same as saying 10 to the power y equals x. So the first part of this section is just converting between logarithmic here and here and here to exponential form. So now I have at the top here, big stars, big important statement, a logarithm is an exponent. This is so important to remember because as we go through these, there's a lot of little rules and intricacies of logarithms. You just don't want to get lost in them, so I'll remind you a lot. But a logarithm is an exponent. Now specifically, log base a of x, it represents the exponent to which a must be raised to obtain x. And if you look at the definition here, if I raise a to the y power, I get x. So directly speaking, log base a of x is an exponent. It's the exponent which you must put on a base of a to obtain x. So a more informal way that I like to explain this is to say log base a of x is, quote unquote, the power of the base a that gives us x. So it's the power, the exponent you must put on a base of a to result in x.